Good morning and good evening, everyone. I just want to make a couple of initial comments before we get into the content. Okay. So the first thing is going to be classes will be from Monday to Friday, US time. Okay. So we'll be having the classes Monday to Friday, US time. But I'm not sure who are the people who are joining from India. For them, for Indian people, it will be from Tuesday to Saturday, Tuesday morning to Saturday morning. Okay. And that is one thing I kindly want you to observe. That is the first thing. And second thing is, since there is going to be a daylight savings that is happening from next week, okay, I'm planning to move these classes one hour ahead. Like right now it is at 8:30, right? EST. So it will be from 7:30 p.m. EST, okay, which will be 6 o'clock in India at the same time. So Indian time is not going to change. So it will be 7:30 p.m. EST and 6:30 p.m. CST, basically. That's how this planning is expected to happen. Kindly make a note of that one. And we'll be having the class tomorrow also as well. So tomorrow would be the last class where the list of demos, what has been planned, will be completed. And we'll be entering into the first session of Snowflake, where we'll be creating a 30-day free trial account and then start discussing the components within that Snowflake. That is one thing that you need to understand. Okay. And the second thing that I'm planning to let you know is, see, Snowflake itself is a SQL-based data warehouse. SQL-based data warehouse. Okay. Throughout the 40 days period and 45 days, how many days we are going to take these particular sessions, what we are going to do is that we are going to discuss only these SQL statements only, like DDL, DML, DCL, and then ETL related things also will be done only with the help of SQL only. Okay, that's the reason. That's the reason. What happens is that there won't be any special set of SQL prerequisite classes that are really not required, because what we do in Snowflake is only the SQL part only we are going to take, because Snowflake itself is a relational data warehouse which exists in the cloud, and the other thing is it is a software as a service. That's why we deal with SQL in and out. That's why a separate SQL thing is not really required. And in case if you feel that you are lagging a bit in SQL, I can tell you the websites or the links where you'll be able to do a interactive session, and then you'll be able to learn it for free. That should not be a problem. Okay, that's why having a mid-core knowledge of SQL is really not going to be a showstopper for doing these particular things. Okay, hope you make a note of this one also as well. Okay, now welcome back. So this is not day 2. This happens to be the day 3 of Snowflake bootcamp training. And what we are supposed to do is we'll be discussing a bit of data warehousing and OLAP concepts in a very lightweight manner. Okay, I'm not going to discuss anything heavy today. Okay, so yesterday I hope I have completed the concepts of cloud computing with respect to
laptop.
I hope yesterday I have covered the concepts of cloud computing with respect to infrastructure as a service, platform as a service, along with the software as a service. We also discussed something like what is public cloud, what is private cloud, and what is hybrid cloud also as well. There are companies which will try to take the advantages of both public and private cloud, and then they'll keep the content in both those two cloud environments also as well. Those things also we discussed. Okay, and then finally I have told you, right, when you're having Sahaja, when you have something like infrastructure as a service, platform as a service, and software as a service, what happens is convenience will be there convenience, more flexibility will be there in the case of infrastructure as a service. Okay, but when we move towards the SaaS, what is something that is going to be more flexible? Is it more convenient or more flexible?
More convenient.
Yeah, more convenient when we use this one, but we'll have this less flexibility in the case of software as a service. Okay, all those particular concepts we discussed, and then we concluded Snowflake happens to be like a Gmail account where you log into that Gmail account and then do all the sending emails, composing emails, and all these things you do. So similarly, also as well, we really don't deal with the underlying components of your infrastructure, but will be there only at the application level, and then we'll deal with this one. So I have told you, like in the case of software as a service, nothing will be there in our control. Okay, but what will be there in our control? Nothing will be there in our control. In the case of platform as a service, at least the applications and data will be in our control. Okay, those differences what we have seen. And before we go into the next concepts, could anybody tell me what are the major components of a cloud computing system? What are the major 4 components that we discussed? What are something that we are expected to have here? Major 4 components. First one, we need to have the second one, and we need to have the third one and fourth one. What are the 4 things that we need to have? In case if you don't
Compute,
have
storage,
you not be able to put it.
networking.
Yeah, yes, Kamalakar. The first thing what Kamalakar is saying is networking. This is important.
Compute, storage.
Yeah. We need to have something called as a compute, which is really important. We need to have something like the storage. And what is the next one?
Yeah.
Network and security.
Okay, that security comes under the part of networking only. But the other thing what we talk about is the database.
Yeah.
Right? We need to have the compute, we need to have the storage. Storage will include the primary memory along with the secondary memory also as well. Primary memory along with the secondary memory also as well. And then the database, that is a place where we try to keep all the information basically. And then when we are working on a particular system, what happens is your environment will be containing a collection of different computers. That's why they need to be interconnected, and that interconnection is being specified with the help of this networking also as well. That's why these are the 4 primary components any cloud computing is expected to have. Okay, now so when you get into this Snowflake, because since we start discussing with respect to your data warehouse, and one more thing, we are not here to discuss the traditional data warehousing concepts. We are here to discuss the modern data warehousing concepts. That modern data warehousing concepts is mentioned in the form of a data lake. Okay, so these are all the buzzwords that you are expected to understand. One is online transaction processing. The second one is online analytical processing. The next one is your data warehouse, database, ETL, ELT also as well. And then you have these data lakes, star schemas, dimensions, facts, master tables, and transactional data. So these are all the prominent words that we use every now and then within this data warehousing concepts, and within the Snowflake also as well. Most of our discussions are going to be centered around these particular concepts only. Okay, so can anybody give me an example of an OLTP system? What is an example of a OLTP system?
Normal DB.
Sorry?
Banking
Online.
system. Banking
Yeah.
system. It's a banking system where it's
online transactions.
Yeah, online transaction processing is a OLTP system, right? Like any ATM counter is a OLTP system. When you go to the retail store, the sales counter, the system what you're having there is a OLTP system. These are all the different OLTP systems. What we do, that is the place. That is the place where we try to do all these business transactions, right? That is a place where we try to do all the business transactions. That is a OLTP system. And what is a OLAP system? It is nothing but a system that contains the data used for reports and analysis only. That contains the data that is used only for the reports and analysis, and such type of system is a OLAP system. Okay. Now my question is, without having OLTP, can you think of the existence of OLAP? If you don't have a transactional system, can you have this reporting and analytical system in place?
No.
Yeah, we can't expect to have this reporting and analytical system in place if we don't have the transactions. If we don't have the transactions, that's why initially the OLTP system should exist. Then what we need to do is that we need to have this OLAP system that can be used for reporting and analysis. Then in such a case, what is a data warehouse? Can anybody define what is a data warehouse? How do you define a data warehouse?
Yeah, it is integrated, non-volatile, and we can able to. Yeah, it will be data warehouse is.
Basically, it stores the summarized and aggregated data.
Yeah. Data.
So it's the staging or maybe the storage area where your data is extracted, transformed, and loaded.
Yeah. So yeah, thank you so much for all
In
your
a structured way.
Yeah, in a structured way. Yeah. So one thing what we can say is that it is a database that is used only for reports and analytics. Right? That is a simple definition that we can say here. It is a reporting and a business intelligence system that we can use for the reports and analysis. Okay. So the first thing what we do is that this is your OLTP system here, basically, right? See, all the ATM transactions, whatever you do, is something that goes into this OLTP system. And from this OLTP system, what we do is that we bring this data into this OLAP. We bring this data into this OLAP. And from this OLAP only, what we do is that we try to produce these reports and analytics. We try to produce these reports and analytics here. So this is what is your business intelligence solution, what we call as OLAP, basically. Okay, so the process
Ravi
of
one question. So I heard there are some reports that are needed from the OLTP systems also. Is that a real possibility in the real?
Long back, Andy, you generally produce the reports from OLTP systems. We call those reports as MIS systems, management information systems. We do, but nowadays what is happening is that was long back. Nowadays what is happening is that we have to have an analytical system. Okay, from that analytical system only we try to produce the reports. Of course, there are so many companies that will try to generate the data from your transactional systems also as well, that exists. We're not denying that one. That exists, basically.
Okay, thanks.
Yeah, no problem. So we'll talk about this massive parallel processing system later, but what data warehouse is not? A data warehouse is not a copy of the source data with the name prefixed with DW. Okay, it is not the copy of multiple tables from various systems union together into a view. And another thing is that it is not a dumping ground for the tables for various sources without no much design put into it. It is not something like when you see this diagram, it is not something like when you are trying to transfer the data here, you are not really dumping the data. Okay, we are not really dumping the data, as well as we are not really transferring the data here. It is not a copy, but what happens is there is so much architecture that is involved in creating this OLAP system, because in the OLTP system, obviously the data happens to be very summarized. The data happens to be very summarized, but in the case of OLAP, what we do is that in the OLTP system, the data will be in the detailed manner. Suppose when you have your data in the OLTP system day-wise, then in the case of OLAP, what we do is that we try to summarize at the month level or at the quarter level or at the year level. This is what is treated as OLAP. So there is a major difference between OLTP and OLAP. Okay, so this point makes sense. It is not a dumping ground for the tables. okay, without much design put into it. There is a lot of design that need to be put into this particular thing here. So that's why, see here, a data warehouse is where you store data from multiple data sources. Can anybody tell me why do we have these multiple data sources? Why do we have these multiple data sources?
Because data is not in the one system.
Yeah, the data is not in one system. May I know the reason, Ravi Kumar, why data is not in one system?
It is like online transaction processing is happening in different places.
Okay, suppose you are working on a global enterprise where your business operates in multiple places. Okay, when the business operates in multiple places, what happens is that each region will be storing the data in its own separate database, assuming that. Okay, then in such case, what happens is the data gets stored in multiple data sources. That is one option. And second option is, say, in 2000, assuming that I was using something like Oracle platform for the purpose of storing all my business transactions. Okay, nowadays there are so many things that have come, like Microsoft CRM Dynamics has come, Salesforce CRM has come. So when the technology is also changing, obviously what I do is that I really don't store the data in the old legacy environments, right? In the MS Access, Excel sheets, or Oracle databases, I really don't store, because so many latest versions are coming. That's the reason I prefer them to store them in the new and modern systems also as well. So as a result, what happens is your data stored in these multiple technologies and multiple platforms. That's why your data exists in multiple data sources. Okay, and a data warehouse is where you store the data from multiple locations, and you use these locations for the purpose of reporting and analysis. And one more thing is that it acts as a central repository for many subject areas. For example, you see here, this one. This is your business. In the business, don't you have these many databases that exist, Kamalakar? You can have that one, right? Order controls, purchasing, finance, production control, parts management, logistics, like that. You can have multiple places where your data exists. Okay, and each and everything is stored in their separate databases, basically. Okay, now when you try to take the finance department, what they do is that they'll try to take the data from production control, okay, as well as from the logistics and the orders also as well. They'll try to take the data. So when multiple departments try to take the data from their multiple databases, Sajid, don't you think that your efficient way of reporting is going to be in confusion and it is going to be in chaos, right? Basically.
Yes.
So that's the reason what has been decided is, now this is something that we have not decided. That was decided in 1980s and 90s itself. What they have decided is instead of trying to do the reporting by connecting to these multiple source systems, let me try to put the data into a common platform. And what is that common platform? That common platform happens to be the enterprise data warehouse. And then within that enterprise data warehouse, then what you do is that you use that enterprise data warehouse for your reporting and analysis needs. That's why that is what is basically treated as an enterprise data warehouse. That's the reason what is being told is, see, while you are working in Snowflake also as well, you will not be using your normal SQL statements, right? You need to model your Snowflake database also as well. That's why it is not a copy. Okay. And then Sirisha, is it a dumping yard? Is your data warehouse is a dumping yard? Or Madan Mohan, is it data warehouse is a dumping yard? Data warehouse is not a dumping yard, because what we need to do is that we need to put a lot of efforts and architecture to design the data warehouse, and then use the data warehouse for the purpose of bringing the data from these systems. That's why these systems, what you're having here, are basically treated as source systems. Source systems. And what is the process that is being used to transfer the data from the source systems into this data warehouse? What is that process called? What do we call that particular process? Can anybody tell me, like?
ETL or ELT?
Yeah, that particular process is treated as ETL and ELT process. ETL and ELT process. Like first thing is that we need to extract the data. Extraction is the process of pulling the data out of all your source systems. That particular process, what we do is that we call that one as extract. Once we extract the data, Kamlakar is telling something like T. What is the T? What is the T?
Transform.
Transform. Yeah, Ravikumar, can you tell me why should we transform?
Because requirement basis.
Hmm?
Data should be not in the per requirement. We have to come into the.
Not all the data is
correct
required
correct,
for analysis or reporting purpose.
Yeah, not all the data is required for analysis and reporting purposes. And one more thing is that when the data exists in multiple platforms, I'll tell you my case. We are working in a insurance department. Okay, in the insurance department, we have two lines of things that we do. We write the policies, and we have the claims also as well. Kamlakar, policies and claims, will they be in one system or two different systems?
Different systems.
Yeah, policies is a separate business, and then claims is a separate business.
Claims.
Yeah, because when you want to be covered with respect to your health, you need to take the policy. If you don't take the policy, you will not file your claim. That's why claims and policies are two different lines of business. Okay. Now, when I'm trying to create an enterprise data warehouse, what happens? I need to bring the data from your policy, as well as I need to bring the data from your claims. So when I'm bringing the data from two different systems, the data might not be consistent with each other. Okay, how the data will not be consistent with each other, let me tell you with the help of a small function here, small thing here. 1 minute. When I try to add a new slide here, see here. My name is Ravikumar. Earlier, my name was being stored as Ravikumar Ravi. Okay. Now, this is assuming that this is in my policy. Okay. Now, in the claim system, what has been done is that they started storing this one as Ravikumar. Okay. And whenever they are making the payments to me, what they did is that they're trying to store the data with like this. So Sahaja, is this Ravikumar Ravi, Ravikumar and Ravi K Ravi are same or different?
Same.
They should refer only to a single person, right?
Right.
So when they are supposed to refer to a single person, what I need to do here, when these three are coming from different sources, okay, and when I am expected to store the data within a single system, okay, what I need to do is that, shall I store them in as three different names, or shall I store them as in one name here? You tell me. I need to store them as in one name here, right? I need to store them as Ravi, Kumar, whatever it is. This is my consistent form, because even though I'm represented at three different names in three different systems, I need to map them to this place, Okay. I need to map this one to this place like this. So this is what is called as transformation. This is what is called as transformation, trying to convert the data from inconsistent form to this consistent form. Who are the new joiners today? The reason I'm asking is I just want to get in touch with you. Madan Mohan, is it your first class? Ram, is
Hey,
it your first?
Hey Ravi, Ramanjanil. Yeah, this is my first class actually. This is
You are from
Raman.
India or from US?
I'm from US.
Okay, cool. So please try to follow today, and then what I do is that maybe tomorrow I'll touch base with you, and then please go through those recordings also as well in case if your company is sharing, and we'll touch base tomorrow, and then we'll talk about what are the things that has been covered. Is it okay with you?
Yeah, sure.
Sure. So this is one form of inconsistent pattern to this consistent pattern. This is one way. And second way, what we do is that suppose you have something like day-wise sales. Day-wise sales that you are having here. So something like 11/1/2023, you are storing the data, and then assuming that you are trying to store the data till 12/31/2023. You're storing the data for these 2 months in the source. But in the target, what I'm expected to do is that I'm expected to store the data not in day-wise, but in week-wise. So that means that how many records I get here? In 2 months, I'll be having something like 8 records that should be stored. And here I'll be having something like 60 records. So what is the process of converting those 60 records to these 8 records? What do we call that one? We call that particular process as summarizing the data. We call that particular process as summarizing the data here in this case, right? So this is what is treated as inconsistent to the consistent form, and this is what is treated as a detailed format to the summarized format here. So that means that what we do here is whenever you have the data that exists in your data warehouse, what we do is that all the data might not be in the same format. We need to transform. Okay, so for the purpose of transforming the data, what we need to have is that the transformations cannot happen on the fly. See here, I cannot do the math, right? Suppose when we talk to a math genius, okay, what happens is that you give some 100 numbers, and then what they do is that they'll tell you the sum of those 100 numbers or the multiplication of those 100 numbers straight away. From the tip of the mouth, they'll tell you. But we can't do this one here. So in the sense that what we need to do is that assume that this is your source system and this is your DWH, data warehouse. Then what happens is that I cannot immediately transfer the data like this. That means that first what I need to do is that from the source, I need to bring the data to a temporary platform. I need to bring the data to a temporary platform, and the temporary platform is called as what, Ravi Kumar?
Staging.
The temporary platform is called as the staging layer, and from this staging layer, what we do is that we try to load the data into this data warehouse. Okay, so this particular process, what we do is that this is basically treated as E. This is E, that is the extract, and this is something that is treated as T. This is T here, and this particular process, what you are having here, is basically treated as ETL process. Earlier 10 years ago, when we were doing these things, people used to call us as ETL developers. ETL developers. Also, people used to call us as ETL architects. There is something called as ETL testing, like that used to be there. Nowadays, they are not called as ETL developers. Can anybody tell me what is the other name for this ETL that is now being called?
Data engineers.
We are being called as data engineers.
Data warehouse.
Yeah. Sorry, Ravi Kumar?
Yeah, it is a data warehouse also, we can say that.
When we are developing this ETL process, those people are called as data engineers. Okay?
Okay.
Those people are called as data engineers. In the Snowflake also, much of the time what we'll be doing is will be doing the process of this data engineering only. But in the data warehousing, what we do is that we don't do this ETL process. We don't do this ETL process. But what we do is that we try to do a process called as ELT, that is called as extract, load, and transform process. That is basically treated as extract, load, and transform. Can anybody tell me what is the major difference between this ETL and ELT? Sirisha, you're trying to tell something?
In ETL, you will extract and transfer, then load it. But in the ELT, first you load as is, and then you will do the transaction at the end. So that way it would be faster.
Yeah. So Kamalakar is telling one process called as is. As is means what we are doing is that we are trying to dump the data. We are trying to dump the data, that is called as is process. That means that when you have the source system that exists, automatically what happens is I call this one, the dumping area is what is called as a data lake. And one more thing is, in all the above slides, what we are discussing is we are talking only about the relational data. Relational data. So in what form the data is being stored within the relational data? In the relational format, the data is stored only in the form of tables, right? The data is being stored only in the form of tables. But when you talk about the data that is existing in the real world right now, in the current scenario, the data is not only in the relational tables, right? Tabular data is basically treated as structured data. And then there is something called as a semi-structured data. Can anybody tell me some examples of semi-structured data? And you also have another type of example, that is what is treated as unstructured data.
Semi-structure is JSON.
Yeah, semi-structured is JSON. XML files are semi-structured. Okay. HTML files are semi-structured. Okay. And whenever you're trying to read the data from your log files, those log files are semi-structured data. Okay. But IoT devices, Internet of Things, when they are trying to send you those analog signals and digital signals, or the bitmap images, or the images that you take from the satellite images, those things are treated as unstructured data. Such type of devices are basically treated as unstructured data here in this case. Okay. Now the question is, for reporting and analysis, is it only the structured data that is required? Or for reporting and analysis, we need both structured, semi-structured, and unstructured data also as well? I'll tell you. Last week, my car has a severe accident. Okay. Then what I did is that I submitted a claim to the insurance company saying like my car has crashed. Okay. Then what they have taken is they have taken the statement, and then they have entered the claim in the claim system saying that Ravikumar car has been crashed, and then they reported that one to the insurance company. That is okay. But now what is happening is that those people are asking for the estimate. Sorry, those people are asking for the images of the car. Can you send me the images of the car that has been damaged? Because we would like to take an estimate. What is that estimate? That estimate is something like how much damage has happened. Okay, and then they'll give you an initial loss estimate. How much would be the loss? So for that particular purpose, Sahaja, is it something like only the structured data is required, or else those photos what we are talking about is also required for reporting and analysis?
Those pictures also required, so unstructured data.
Pictures also are really required for reporting and analysis. That means that what happens is that you are not counting only on the structured data, you are also counting on the unstructured data also as well. Another example I'll tell you. We live in Florida. Okay, Florida is continuously hit by a lot of hurricanes, and especially in the month of August, September and October, there will be a lot of property damages that happen. Property damages that will happen. Okay, so what happens is that whenever the estimators come in order to take the estimate of the loss or the damage, all the people cannot come to the houses and then they can take the damage report, right? Because there will be some hundreds and thousands of houses that gets damaged. Then obviously what they do is that they'll try to take the satellite images, okay, or else they'll try to send those drones, and then those drones will be able to take those satellite images also as well. So those images are also really required for your reporting and analysis also as well. So that's why the days have changed, and then the way we try to take the reporting and analytics also has changed. That's the reason relational data itself is not only sufficient for reports and analysis, but we need to have that unstructured data, and semi-structured data should also be required for your reporting and analysis. But Kamalakar, you know that the data warehouse is a relational database, right?
Yeah.
When you go to this data warehouse here, what we decided is the data warehouse is a relational database that we discussed here in the back. See, this data warehouse, what we are having here is a relational database. But the pictures and other things what we are talking here, they are nothing but your unstructured data also as well. So that's the reason before I send the data from the unstructured form into the structured form, what it is that I'll try to create a data lake. And what is this data lake? This data lake is nothing but a modern computing platform. This data lake is nothing but a modern computing platform. Okay, what it does is initially we dump all the data into the data lake. So for the purpose of dumping the data into the data lake, Kamalakar, do you think that any transformation is required, or else we simply take and then dump?
Yeah, we can dump.
Yeah, we
Mostly
can
we
simply
dump.
take the data and then dump. That's why this data lake happens to be a dumping yard. This data lake happens to be a dumping yard. So if you try to call this data lake in AWS, then what we do is that we call that one as an S3 bucket. S3 bucket. So that's why in the case of this source, what happens is the data from your source systems, the data from your structured data, the data from your the data from your semi-structured as well as the data from your unstructured is getting dumped into your data lake directly. So we extract and dump, and that is what is called as the EL process. Now, once the data has been totally dumped in the as-is format as what Kamalakar has told, then what we need to do is that we need to transform, because not all the data is required for reporting and analysis, right? We need to filter, we need to transform, we need to make the data consistent, we need to aggregate the data. All these particular things has to be done. All these particular things has to be done before we try to dump the data into this, before we try to copy the data into this data warehouse. So this is the place what we do is that this is your data warehouse. So once the data is there in the data warehouse, then what we do is that we use this data warehouse for reporting and analytics. We use this data warehouse for reporting and analysis, basically like this. This is the way we try to do this one. So here, this process, what you're having here, we call that one as this process is basically treated as EL process. This is what is your EL. We are extracting and then we are loading as it is. And then in this particular process, what we are doing is that this is the place where we are trying to transform the data in order to load the data into the data warehouse. So this particular process is treated as ELT process. Like when your data strategy, when your data architecture, or when your data roadmap is having a process like source systems, then followed by data lake, and then between the data lake and the data warehouse, you can also have something like staging layer that exists. This is a staging layer that exists. Once the staging layer is there, then you do this data warehouse and the reporting process. We call that one as a data lake, and that is your ELT process, basically. Okay. Now my question to you is, Sahaja, is data warehouse an advantage or a disadvantage?
Advantage.
Data warehouse is an advantage. Data warehouse coupled with the data lake is always an advantage. So that is the reason what happens is that data warehouse and data lake complement with each other in order to do your reporting and analysis also as well. So this is what is your modern information architecture. So that's why those people who are really experienced and then having a perfect hands-on to create these data lakes and then populate the data into the data warehouses and then do the reporting. The days of Cognos, business objects, SAP, crystal reports, all those reports are gone. Nowadays, people are talking about Tableau. Even Tableau also has become 15 years old. Okay, people are talking about Power BI. Power BI is also 10 years old. Okay, there are so many tools that has come in AWS, like QuickSight is there, Athena is there, and predictive analytics tools are also there also as well. So these are all the different types of tools that are coming. Even Tableau and Power BI are also getting matured, not to do the normal type of old legacy reporting, but what they're doing is they also continue to do your predictive and prescriptive analytics also as well. That's the reason everything is changing. Technology is changing. Okay, the way we bring the data is changing. The way we do the cleaning of data and then loading the data is also changing. That's why the ETL technology is also changed, and then we are being called as data engineers. So when you try to look into the jobs of Snowflake, you'll be seeing something like there won't be any something like Snowflake ETL developers. We'll be calling them as Snowflake data engineers. Okay, and the reporting and analytics, they won't be called as business intelligence developers or report developers. They'll be called as data analysts. So that's why within the Snowflake, we always talk about data engineering and data analytics only. We don't talk that one as ETL or reporting process. That is the thing that you need to understand here. So is everybody clear between what is ETL and ELT process, and what is a data warehouse and what is a data lake? The concepts are clear or not? Please let me know in case if you have any questions. Madan, you have any question?
Yeah, how is Snowflake fit into this?
Snowflake. See, yeah, good question. Snowflake, what it does is, the one disadvantage with respect to Snowflake is Snowflake does not support unstructured data. Got my point? Snowflake does not support unstructured data, but Snowflake supports structured and semi-structured data. Within the Snowflake, the first thing what we do is that instead of creating the data warehouse first, what we do is that we create the data lake. The data lake is also a schema, a relational schema that contains both structured and unstructured data. We keep the data within the data lake, and from there we build the data warehouse and then use the data warehouse for the purpose of taking all those different reporting and analytical needs. That's how the Snowflake provides a very comprehensive end-to-end modern information architecture platform, okay, where the people can have the capability of bringing batch data, okay, near real-time data, and then streaming data, process it, put the data into the data lake. From there, use your dimensional modeling techniques, construct your data warehouse, and then use that data warehouse for your business intelligence reporting needs, and then this data lake for your machine learning and analytical purposes also as well. So that's why when I have shown you this yesterday, you were there in the yesterday's class, Madan Mohan.
No, I didn't realize like there was a class yesterday.
Oh, I'm sorry. Hold on,
No
please. Hold on for a minute, please.
Sure, thank you.
Yesterday. I'm bringing this picture to tell you what exactly is Snowflake. Now tell me, like, can you see the screen here, Madan?
Yeah, I could see.
So, is it not Snowflake providing a complete platform for the purpose of building your data warehouse? This is your data warehouse. This is your data lake. Kamalakar, are you seeing ETL or data engineering here? This is the data engineering that we are seeing here, right? We are seeing this data science also as well, and then the data applications we are seeing here. That means that there is only one platform that we are going to build entirely within Snowflake, and then whatever the data that you are having in this Snowflake can be used for all the different types of reporting. Operational reporting and ad hoc analysis is the long legacy technologies that have been using, but now we are talking about this real-time analytics. Madan, do you understand now how Snowflake is going to fit into this architecture here? So this is what is Snowflake. This is what is Snowflake that we are going to discuss from tomorrow. This is what is Snowflake, what we are going to discuss from tomorrow. That's why Snowflake, in case if anybody is going to ask you, it is nothing but an enterprise data platform. Enterprise data platform, okay, which exists within your relational database format. Because every information what you are storing here is only in the form of tables only. That's the reason whatever the ETL or whatever the ELT or whatever something else you try to do, everything is being done only with the help of SQL only. A pure SQL we are going to use. Okay, once we use this particular SQL, we build the data lakes, we build the data pipelines, ETL pipelines. Okay, once we have the data in this data warehouse or in the Snowflake, then we connect this Snowflake to the different reporting and analytical tools. Such మీరు follow అవుతున్నారు కదా? We connect this data warehouse to the enterprise reporting and analytical tools like Tableau and Power BI. And it will be an end-to-end modern reporting and data platform architecture that we are going to see within this Snowflake. The reason why I have been talking about data warehouse and data lake techniques are, you need to understand these things. And there is something called as ETL and string here. Okay, here when you see this one here, we have something like ETL is there along with the string is there. Why is that ETL existing? The ETL is existing because we have the option of bringing that batch data. What is that batch data? Suppose if the transactions happens today night I try to bring the data. That's why it is called as ETL. But what is streaming data? Streaming data is something like as soon as the transaction happens now, I want the data to be available directly within my data warehouse or in the data lake. That is what is called as streaming. Continuous way of getting the data and then putting them into the data warehouse is basically treated as streaming patterns that we are going to work in this particular Snowflake architecture here. Okay. So having said that, I just want to end today's session with a concept called data lake. What is this one here? You have your data warehouse. See here, data sources are there. From these data sources, we are doing your ETL, and within this ETL, we are building this data warehouse. And within this data warehouse, we are doing this business intelligence and analytical solutions we are building. Within this one, what we did, why did it happen, what happened? That is a normal reporting that has been happening from the last couple of so many years. It is happening. From the last couple of so many years, it is happening. Okay, but when we combine this data lake, in this data lake, Satya, are we having only the relational data here? No, right?
We will do the semi-structured data.
Yeah, we'll be doing the semi-structured and unstructured data also as well. Videos are there, LOB applications are there, sensors and everything else is there. So when the data warehouse is complementing your data lake, then what we can do? We can do this predictive analytics. What will happen? How can we make it happen? What will happen means, what is the probability that BJP will win in Telangana or in Delhi in the next coming elections? That is what will happen. Prescriptive analytics means how can we make a BJP to win in this Telangana? That is what is your prescriptive analytics. So those are the two things that we are going to discuss from tomorrow onwards. Okay, so tomorrow is the last class where we are going to end these demos, and then we'll be doing the registrations like Visual Path and Harsha Trainings will be taking the admissions from tomorrow. Tomorrow we are going to have the session. Session will be at the same time, 8:30 to 9:30, same time here as what we are doing. And tomorrow we'll go ahead and then start creating the Snowflake free trial version, and then we'll start doing the bit pieces of your Snowflake architecture, and then we'll be doing the practicals also as well. So every day we are going to have the theory come practical. We'll be discussing, and then I'll also discuss the course roadmap, how this is going to happen, how many days it is going to take. So probably you'll be here till December 31st, 2023. 2 months you are going to spend here basically, Monday to Friday. Apart from your Thanksgiving and Christmas holidays, we'll be spending this one, and we'll be ending this year with the Snowflake course completion. That's what's the plan. Okay. So I'll stop sharing, and then we'll meet tomorrow. You can join 5 minutes earlier in case if you want, in case if you have any questions, and then we'll discuss, and then we'll take it from there. Okay. Thank you so much for showing your trust and confidence to make this Snowflake thing. And this journey is going to be a memorable journey. It will be remembered forever. And my goal is in the previous batches, this is the 6th batch I have told you, right? In all the previous batches, people completed the course. They are in the process of doing the certifications also as well. And a lot of people also have started preparing their resumes and then getting into the jobs also as well. That is also happening. I don't say that they have got a job today, but they're in the process of attending the interviews and then trying to get the calls. I just want to play a fair game. Nobody has got a job from the last 15 days, but they're getting the vendor calls, as well as the resumes are being submitted to the clients. And people are really looking forward to complete that certification also as well. That is how the course will go. So I aim towards certification, as well as I want to make you to get the job ready. But at the same time, I'll be fair enough. There is no any job guaranteed program that is there in this particular case. It is all your hard work and passion that will make you ready for the IT environment. Okay. So thank you so much once again for joining, and then looking forward to see you tomorrow in the next lecture, and then we'll take it from there. Have a good evening and good morning.